Welcome to today's class. Sorry about the short delay. I was just busy finishing uploading the work for today. The homework is already uploaded. You can find it on Google Classroom under Matrices, and you will see we have basic matrix operations. There's a PDF. The PDF is the one with the questions that we will be attempting hopefully over the weekend. And then I have also uploaded a sheet where you have to put in your name, your surname, and then add a file. So the file is the questions you can answer on a separate on the book or in the book or on a separate piece of paper, and then you can use the Adobe scan to scan it, and then you can upload it over here. So that is basically how you will upload it. It will ask you from a file. You will select from your device, your phone device, and then you will just select the file that you need to upload, and then we can put it later on for marking as well. So those are the activities for today. Is already up. Okay. So you can see there. So once you submit the file, it will show me here that you have turned it in as well. That is basically what we require from you. It's just a bit of work, practice questions, which are very important. The more you practice, the better you will become in understanding this. And please note, very important also is the questions that I am posting on Google Classroom. As I've said before, that matrices has not been in any of the previous examinations. I will just confirm with higher level if it was in higher level, but I know from previous examinations or old question papers, you will not find this this topic in them, and that is basically the problem. Okay, so it wasn't previously inside there. I'm just quickly checking any higher level paper. If we have any form of matrices in them, but from what I know from the syllabus, it wasn't inside inside the question papers, but they have included it for you guys, and this is why your examination and your grade 11 counts a little bit more than the old grade 12 paper. So this is the two papers for higher level. As you can see, it's high level, but there's no matrices involved. So only in the very old ones, I think from the 1990s, if you have those question papers, you will find matrices included in them. So that is basically, this is the questions that you will be able to answer, hopefully by the end of today's lesson. And I hope we participate and ask a lot of questions, because it's gonna be a little bit tricky. So first and foremost, let's quickly just go through the homework of yesterday. That way we can at least see if we can understand what is going on here, because the homework will help us understand the operations that are going to be happening today. And that is basically what we want you to do. So if we can ask anybody to give us the answer. Here we just asked for the dimensions. So if somebody can give us what is the dimension of the first matrix, and then we also want the dimension of the second matrix, and we also want the dimension of the third matrix based on what is available in front of you, just to see if you understand a little bit what is going on. Good morning, and please confirm you can see my screen, and let's also communicate and talk to each other. I think today I'm not rushed. So today I have enough time for you guys. So let's make it as productive as we possibly can. And please, if you still have friends that are attending class, please inform them as well that we have started. I can see some of the regulars are here, but I'm missing a few regular students as well. Can you guys hear my voice? Is it clear? Is it not clear? Hello, am I coming through? Okay. Who attempted the homework? Let me just ask that. Just click on the hand icon if you attempted the homework. If not, that means you will have to either go through it one way or another. I will just be doing a few of them, and then the rest you will really have to go through it. Trust me, this is a new topic. If you don't do anything, guys, it will be very difficult to understand the next problems that are coming up. And I'm going very slowly with it. We have small bits of sections that we are completing. And every time we complete one of those sections, then we have an activity for it. It's a new topic. All right, so we have to practice. Thank you, Napume, for attempting the homework. Maybe you can give us the answer for one of the number twos, A, B, or C. And I don't know if Pinky is talking or attempting to raise your hand. I don't know who's Pinky. At least, guys, try to put your names, real names on there, so it's easier for me to respond. Otherwise, some of the names is very tough. I might say something that I'm not supposed to say on the record. Okay. Okay. Napume, can you give us at least the dimension of this A? We just need to say what is the order, what by what, row by column. That's basically what we are asking for. It's very important for us to understand this, because the next things we are doing, we will be focusing a lot about the row and column. Okay, Napu says, I don't understand. Okay, Loida is saying it is a P by 3, but please don't say by 3 is in, we are writing it down. So say at least like this. Okay, Loida. So that is correct, Loida. For number 1, it is a P by 3. The rows are 0, 0, 0, 1, 1, 1, 1, 2, dot, P. So we know that the rows are ending at P, and the columns we can clearly see there's only 1, 2, 3 columns. So P rows and 3 columns. That is basically what we have over here. All right. Anyone to attempt B? Loida, your answer was correct for the first one, but instead of saying by, let's always try to put an X for the by, or the multiplications for the by. Anyone to attempt B, and anyone to attempt C? You can also type it in the chat so that we can also see if you can understand. We need to understand what's going on here, because the next things we are doing will be very difficult to explain if we don't understand anything. Okay, Jay says that the second one is what do we call it? 0 by 5. Okay, I don't think it is by 5, because there is a little trick here that you have to take note of. Okay, So there's a little trick here that we have to take note of. Okay, and Napume says we just need to explain why is it a P times 3, okay? While J is sorting out number B. Okay, so let's quickly look at A over here. Why did we come up with this answer over here? So first thing we need to do is when we are asked the dimension or the size or the order, we first count the rows because the first number that we want will always be the rows, and then the second number will be the columns, okay? And so we check the rows. We have 1, 2, 3, 4, 5, and this dot means it's continuing, all right? Continuing, and then until we have P, okay? So P is always like the row P, P, P. That is what we have there. So we know that this will be P number of rows. This is P with a number here. We don't know what that P is, and so forth until we continue forever. Okay, so that is the rows. Okay, for the columns, we basically go instead of left to right, we go up and down. So I can see there's one here, there's another one here, and there's another one here. So the columns, I can definitely see it's 3 of them. It's not continuing anything this side. Okay, so therefore the 3 for the column is correct, but we don't know where the row is stopping. Okay, that's just that letter P there to represent, okay, we're going down, 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 P, and then we have P's later on. So since we don't know where it's stopping, we can also just replace the unknown variable with a P. In that case, we can now say it is P rows times 3 columns, okay? So the rows continue until P, that's why we have a P. By the 3 columns, we can clearly see there's only 3 columns. And I think Ray J has reattempted the number 2, and he says it's 0 by M. Since we have an M over there and a 0 here at the bottom, since we don't know now how it's continuing, here it said it was N1, N2, N3, dot, 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 NM, and then we have again a 0 over here. So in this case, where the 0 comes into play, right? This zeros here at the bottom is not very significant, so we don't need to worry so much about them, all right? So all we need to say, it will be an N by M, okay? Because 0 is its element itself, and 0 can also be included somewhere over there. So we cannot say it's 0 columns, 0 rows by M columns. Otherwise, it will become confusing. If you say 0 rows, then where's the 0 rows? There must always be at least 1 row. So the row and the column value must always be greater than 1 or equal to 1. That is what we have. So this was just trying to confuse you a little bit. But focus on the NM because we don't know what N is. We don't know what M is. So we'll just call it N by M. And when N and M comes up, then that's what we will have for it. And then is there anybody for the last one? To attempt the last one? Napu, maybe you can try and attempt the last one. Napume. Since I've explained the first one, it should be a little bit easier to attempt the last one. It's okay, yeah. I see what Loida is saying. You will notice, let me go back to the classroom quickly and clear this off. You will notice on the classroom, I also posted new material that was now before 1 o'clock. And I can see Napume also asked the very same questions. that we have over here. So I added the Greek alphabet, and this, I always say that as mathematics teachers, we have neglected to teach our African learners about the Greek alphabet. And these are things you will always find in all the question papers of mathematics. One way or another, you will be seeing them there, okay? And this is where our problem is. So I included this to show you that the only reason why we use the Greek alphabet in mathematics is because mathematicians, we do not like English. We hate English letters. We hate English language. We always want to separate mathematics from English. And because we also don't want to keep using the English alphabet for everything, the X and the Y and the A and the B and the C and the Ds. So we revert to the Greek alphabet, which is very specific and have interesting symbols that we can use. So common symbols that you will see is sigma over here, which represents sum. You will also see theta. This is what we use for angles. All the angles in the triangle, we always say angle theta. You will see alpha, you will see beta, you will see gamma. This one is delta, epsilon, and so forth. So this delta y, delta x, you can see the delta that we use for change in y, change in x is the triangle over there. You always saw me, I say always delta y over delta x. That represents our change in y, change in x. And you will see the small sigma over here, this one that looks like this, and the mu or mu, the one over here, we normally use for means, averages in statistics, and so forth. And when you are going to be doing, if you go to AS level, you will be looking at more of the symbols again, where you will be also using them to calculate. So this is just like variable placeholders that we are using instead of the English alphabet. Oh, and look at this one, pi is also there. So we just use this symbol for pi, and that's where it's coming from. So if you have time, go through them as well. It will be a good exercise just to learn or read about them and so forth. Omega, you have seen that symbol a lot. We also use this omega, and for mathematicians, we have omega 1, omega plus 1, omega plus 2 to depict the largest number that we can calculate at a later stage, all right? And this is also what we have in terms of the Greek letters. So the ones that you see in the questions that we have, we are using now lambda and we are using beta, okay? I hope that makes a little bit clear. So this one, beta and lambda, okay? So those are the two ones that you are actually seeing at the moment in the question over here. So we have lambda and then we have beta, all right? So that is basically, it's not an X, it's lambda, and that one is beta. So that is an extra lesson in between. So I knew that you will ask, somebody will ask me the questions, and I also hope that I have answered Napume's question, that you will see these symbols a lot as we continue, and don't be afraid of them. It's just, we are replacing the alphabet letters, N, M's, we are now changing them to Greek letters to try and say we are unique from, what do we call it, English language. That's the only confusing part there, right? So I think, Loida, you can answer the question now, since I've explained what the two are, I know these symbols are not on the keyboard, so if you are able to write down, you can use the drawing tool and then just write it somewhere here, the answer, so that we can at least see if you understand the answer itself. All right. Okay. Yeah, that was the okay, yeah, that is correct. Napu, okay, B times the upside down Y. Let me just bring this in here so it's also seen there. Okay, so that will be the beta, right? So we normally do the beta like that, and by, and then we have this lambda that we have there, beta by lambda, and that's how we call it. Okay, it's just a nice way to say it. Okay. Yeah, thank you guys for the participation. It's always good that at least if you understand what's going on here, and also how we got the answers very quickly, then it becomes also an easy process. So most of you have seen that we normally, to get a quick dimension, we try to go to the last element in the matrix, and then those last two row columns is normally what our dimensions will be. Okay. And that's why Jay also took the O over here, but the O is not significant. We cannot say 0 rows. So we rather go with this N and M, or you could say N plus 1 by N. Okay, so you can also say N plus 1 by M, because the zeros make an extra row. And you can also say because the row is the only one that is increasing, but the columns are not increasing. So N plus 1 by M, that's also a possible answer. Or you can say N by M. We will also accept that because we don't know what the value for N is. It could be N plus 1 is still just N. So that's how we explained it. So the bottom part over here, I just want to quickly talk about some things that are very interesting that I have not mentioned before, but we will be mentioning them later on today. Matrix, what is a matrix? I think you have to know, this is from the first slide that we have. Maybe you will see it again. I will leave it blank, okay? Arranged in what and what, okay? The order of a matrix is in accordance with the number of what and what. So that will be also interesting for you guys to answer. And then we have a 4x3 matrix has how many what and how many rows and how many columns. A what has only one column, a what has only one row. And this is basically the questions that we have. So a column matrix or a column vector has only one column. A row matrix or a row column has a row vector has only one row. Matrix with the same number of rows and columns. Now this one is interesting. We will talk about them today. But if you went ahead and tried to see what we call them, then it's fine. And what has only one element. Okay, only one element. That is also a important point to look at. So it only has one element, that is now either our magnitude, or as we can you can have various ways to also look at it. So a square matrix, okay, that is now already answering the top part already. So the questions was just there to warm you up. And over here we have state the order of A. So again, before we ask you for a dimension, here we are asking you for the order. So this question you should be able to answer. In the matrix A, write down the element R4, C2. So you go to matrix A, you look for R4, C2, and you notice R4 is there, C2 is there. You will give the answer to that. We continue. The parts that we did not talk about is the following. We did not talk about a diagonal matrix, okay? We did not talk about a zero matrix. And write down the elements leading the diagonal matrix. So we did not also talk about the diagonal matrix of E. So hopefully by the end of today, we will have some sort of idea what these things are all about, okay? So a column matrix, give an example of a row and a column matrix. So that's just an example of the previous questions that we talked about, right? So these examples can either be drawn in as a matrix or it can just be given as a dimension. That's also okay. So that's the that was the exercises that we had yesterday, and today we will continue with our lesson on matrices. Before I continue, is there any question, or is everything still fine? And a yes on the microphone every now and then would also be much appreciated, so that I just know I'm not alone. May I proceed? Is everything fine? Okay. So let's proceed. Every now and then you will see me, I will always stop at the first page over here so that we can always remind ourselves where it is we are going. We've looked at the representation of a matrix, and by the representation is how we will write a matrix using our rows and our columns. We've looked at the order. Okay, so these examples of the order and dimensions that we were looking at also teaches us how to write a matrix in any given order. Okay, and then we look at calculate the product of a scalar quantity and a matrix. So we haven't focused too much on that one, but we will focus it on again, and then we will look at solving problems involving calculations, which is the sum and the difference of any matrices. Okay, so we will first try to complete today's lessons by just stopping at the sum and the difference. We talked about sum is adding and difference is subtracting, and the rest of the other things we will do a bit later on in the next lessons, hopefully on Monday. We will look at multiplication of matrices, and zero matrix, identity matrix, we will look at later on as well. So we will divide this, I think it's about 4 lessons, 5 lessons if we need to for the last one, and then that will be it. And I will also be uploading the first video today, so that you guys can also refresh yourselves with that. So let us proceed. This was just the revision on what we did. I'm just going to move a bit fast so that we talk about these things a little bit later on. That was the activities, spoke about Y matrices, and today we will start with a transpose of a matrix. Okay, so that is where we start today. Okay, so a transpose, now again, some of these things will be new words for some of us. And so we first define what is that transpose of a matrix. And you will notice very similarities to many things that we have looked at before. And that is basically what I will be explaining, slight differences, even though they look similar. So a transpose of a matrix is denoted. So denoted is just telling us written as or given as a to the power of I, or A's complement. Okay, so A complement or A prime. Okay, so sometimes I don't want to use the word complement because that word complement is again used somewhere else. So we sometimes just call it A prime, okay, prime, or I don't want to use the word inverse also because there's another place where we use inverse of a matrix again. So these are I'm very cautious on the wording, because if we get confused with the wording, then it becomes a problem. So it's just saying that if we transpose this, then we want to have a way to represent it. So that is why we call it like AI or A to the power of I. Okay, just something different from A. Okay, and it is obtained by interchanging the rows and the columns. Okay, So we are just switching where something is a row, it will become a column. Okay. So this means that if A has a dimension or an order of m by n, then the transpose of A will therefore have n, meaning the columns becomes the rows, and by m, and the rows becomes the columns. That is transposed. Okay. And if we transpose a matrix twice, we will get back to the original matrix. So this is another way of saying if we have A, right, is therefore equals to A transposed, transposed. Okay. So A double prime is just like, in another sense, if you look at this transpose of a matrix, let's say it's rotation. Okay. But it's not like our normal rotation on the axis, because if you rotate by 180, then you will be in a different state in the normal rotation. But here we are rotating the matrix. So the numbers are in those positions. So we rotate it. And if we rotate it again, we come back to this state. Okay. So the rotations that we are referring to now will either only be a 90-degree rotation, and then just a 360-degree rotation. Those are only two rotations that we will be focusing on. So you either rotate it 90 degrees, and then you rotate it 360. Okay, that is the double I is just 360 to come back to A. So I just want to mention that so that it makes a little bit sense if we are looking at it graphically. Okay. So let's look at an example here. So say, for instance, we have this matrix, matrix A, which is a 2 by 3. Okay. And you will see now I will refer to 2 by 3 as normal. So we have 2 by 3 and 2 because we have 1, 2 rows, and 3 because we have 1, 2, 3 columns. Okay. 2 rows, 3 columns. So that is the matrix we have. Let me just clear the drawings. And if we want to transpose it now, and we are asked to transpose this matrix, then we will be basically converting the matrix since it was, let me say, a 2 by 3, we should have a 3 by 2 at the end. Okay. So let's see if we can get that now. So first we take the first row element in the first row will become the first element in the first column. Okay. Right. This element here, we put it there in the first column. All right. Then we take the element in the second row and we put it in the second column. Okay. So you can see I'm going row element, column, row, column. Okay. And then we do the same thing for the next one. The second element, this was in column 2. Now it goes to row 2. Can you see row 1, row 2? This was column 2's element. And then it's followed by 4, which goes to the next position in that same row, which is there. Then we take the 5, which was in the third column. Now it's going to be in the third row. And that is what we put it there. And finally, we bring the 6. And this is how we transpose a matrix. Okay. So what was in the row, you will see in the first row, let me highlight it quickly for you. In the first row, we had 2, -3, and 5. But now in the first column, we have 2, -3, and 5. In the second row, we had -1, 4, and 6. And now in the second column, we have -1, 4, and 6. Okay, so we just like, if you look at the angle it produced, so we basically just try to flip it in a form of a 90-degree type, but not entirely just normal rotation. So I told you it's not the normal rotation, because normal rotation would have a -1 in this position. Okay. It will have a -1 in this position, and that is not what we have in our transposed matrix. All right, so just take note of that as well. Okay, so even for a row vector and a column vector, this is just basically transposed. So if we have x, y, and we transpose it, then we will have x and y at the bottom. So I've explained this before when we looked at vectors, and we said that we can write it this way or we can write it that way, and it will more or less still be the same thing. All right. This transpose matrix things we will use later on when we are doing determinants a little bit. It will almost be similar, but not entirely. So we just wanted you to get the feeling to it a bit, how we transpose certain things. So we can play around with matrices and or vectors in any way we can. All right. So let's look at some special matrices. As you know, in triangles, you had special triangles. We have right angle triangles. You have equilateral, isosceles, and scalene, and all those things. So the same principle as we have special triangles, we also have special matrices, and they are basically just defined by the names that we will look at. So we have a row matrix. A row matrix only has one row. We have a column matrix. A column matrix only has one column. We have a square matrix. A square matrix has the same number of rows and columns. And you can see this is some of the questions we gave for homework. We have a zero matrix. A zero matrix contains all zeros. Okay. At university level, you will hear about the one matrix. Okay. One matrix just means everything is one inside there. Okay. In the field of studies that you will go, you will be dealing with zero matrices and one matrices later on. For us this year, and we will look at the zero matrix later on, because when we do determinants of matrices and so forth, we need to somehow play around with zero matrices and diagonal matrices as well. Then we have an identity matrix. It's ones going down the main diagonal, okay, and zeros everywhere. So a diagonal is basically just a line like this. Okay, this is called the main diagonal, and we have another diagonal going this. Okay, forming a diagonal line. All right, and based on that, we can now say a diagonal matrix has non-zero numbers on a diagonal. That means on this diagonal, and zeros everywhere, basically. That is what we will call a diagonal matrix. All right, so let's look at some examples of these things that we are talking about. So a row matrix, we just have a row, one row, and we have 1, 2, 3, 4 elements. So it's one row, 4 columns, okay? A column matrix, we have many different rows, but one column. So this will be 4 by 1, all right? And we have a square matrix. A square matrix just implies that we have equal numbers of rows and equal number of columns, all right? So if you have 2 rows, you must have 2 columns. If you have 3 rows, you must have 3 columns, okay? We have a zero matrix. Zero matrix means doesn't matter what we have, everything is just zero, okay? Whether it's a square matrix or a column matrix or a row matrix, if all the numbers are zero, we change that and call it a zero matrix, okay? We have an identity matrix. An identity matrix has ones on a diagonal, on the main diagonal. So identity matrices are normally any identity matrix will either come from a square matrix, okay? We can only have identity matrices in square matrices, okay? Everywhere else, then if you have let's say a 4 by 3, and in that 4 by 3 you have only ones along the diagonal, it will become a problem.